I'll make sure that this is recording. Yes, I think it is. Great. So last time we did the chain rule. So what did you see? If G is differentiable at X, or let's say at the number A, say, and F is differentiable with G of A, then H, let me see if this is good. It's recording good. Yeah, it is. It is. It is. Maybe I should. Yeah, no, it's fine. I think it's fine. If G is differentiable at A, at the number A, and F is differentiable at G is A, then H, which is defined by F composed with G. Have you seen this notation before? F circle G, right? This is for the composition. This means that H of X is F of G of X is differentiable at A. And H prime of A is equal to G prime of A times S prime of G. Right? This is what we saw this time. Great. Okay, any questions on this? We saw many examples. We will also continue doing more examples. But do you guys have any questions? No questions? Great, awesome. Now, what we'll be doing now is we will try to look at, before we do more chain rule problems. By the way, do you like the fact that we do many examples in class, or we should like do less examples and move on? Okay, more examples. Okay. G is differential, and I'm trying not to touch the book examples, right? So you will have the pleasure to do the entire book examples. Okay. Great. Awesome. What do I want? Yeah. So we're going to look at higher order derivatives, second order, and higher order derivatives. Okay, great. So let us begin with the first derivative. We have seen that f is a function. And let's say we have x1 should be less than x2. We said that the average rate of change of f of x on x1, x2 is the slope of the secant line joining x1, fx1 and x2, fx2, right? Is the slope, say yeah, is the slope of the line through x1, fx1 and x2, fx2. So let me just draw a picture. So I have a function f here. I have x2, fx2 here, and x1, fx1 here, and the slope of this line is the average rate of change. Great. Now the instantaneous rate of change is when that interval is very small, right? When the x's are very small, what do we get? The instantaneous rate of change. Instantaneous, well, I mean, here I'm assuming that x is times the instantaneous rate of change, right? X at x equals a is f prime of a, which is just the limit as h goes to 0 of f of a plus h minus f of a over h if a exists. Great. Now, and what do we get? By defining this limit for all a where possible, I get the derivative function. Okay? That's how we got a derivative. We agree? Do you remember this? Yeah. Okay. Now I can do the same thing for the derivative. Instead of doing the rate of change of f, I can do the rate of change of f prime. So let us, when we do the rate of change of f prime, where is the eraser? Here. We look at the rate of change of f prime on x1, x2. Of course, I'm assuming that if f prime is differentiable on an open interval, you don't have to worry about this, containing x1, x2. Don't worry about this. Is what is that? It's just f prime of x1, f prime of x2. What did I write? F prime of x2. Yes. I did not try it, right? I did not try this one. So what is the slope of this line? This is just f of x2 minus f of x1 over x2 minus x1, right? Delta y over delta x, yeah? You see that? What is that? It's just f prime of x2 minus f prime of x1 divided by x2 minus x1. Now, if I make x2 very close to x1, right? Just take x, so fix x1 and take x2 very close to x1. What do you get? You get the derivative of f prime at x1, right? So if a, what do you prefer? You prefer this notation or with the a plus h minus h? What notation do you prefer? No? Doesn't matter? I'll choose then. So, if at x equals a, the rate of change of f prime, instantaneous. Of course, here, I don't know why I'm assuming x is time, but the instantaneous or the local that x is position, I don't know what you say. But if f, the rate of f prime, the rate of change of f prime is the limit as x goes to a of f prime of x minus f prime of a over x minus a, which is just f prime of a, right? You take the derivative of prime if it exists. Right? You see that? A function minus the value of the function at a divided by x minus a as x goes to a is the derivative of that function. Do you agree or not? Yes. It's the derivative of f prime. So it's f prime prime. Okay? So f double prime is called the second derivative of a. Ff. This is the second derivative of x. Okay, great. We can do the same. For f triple prime, and f 4 prime, the 4 derivative, we just, after 4, we just write, 4, and after we just write f4, okay? Instead of writing 7 primes, for example, we just write f5. Okay? Are we good here? Is that clear? Great, awesome. Now, if f is differentiable, does that imply that f is twice differentiable? Is there anything that... So let's take a polynomial, for example. A polynomial which is an integer power x to a positive integer power. A sum of these. You can differentiate this infinitely times as you want, right? You see that? Yes. So a polynomial. So x to the 100 plus x to the 99. Differentiate that. Can you differentiate that once? Can you differentiate that twice? Yes. 3, 4, 5, 6, 1,000 times, right? But at some point you will hit 0. You see that or not? Yeah. Try to see it. Try to convince yourselves that a polynomial is infinitely differentiable. That you have cosine and sine. So cosine x, well maybe you can do an example of that. Cosine x is equal, let's do something else actually. I don't wanna, well no. Let's pick another example. If f of x is x to the 5/3, okay? What is the domain of f? The domain of f is R. You see that or not? Yeah. This is the cube root of x to the 5. Domain is R. Is f differentiable at 0? Is f differentiable at 0? F is differentiable at 0, and f prime at 0 is equal, I mean, we can do it, you can find a formula for f prime, of course, f of x minus f of 0 over x minus 0. So what is that? This is just the limit as x goes to 0. X to the 5/3 divided by x, what do you get? X to the 2/3, right? X to the 2/3, which is just 0. Agree? Yeah, do you agree or not? Now, what is f prime of x? F prime of x is equal to what? To 5/3 x to the 2/3 for all x and r. Do you guys see that? For all. Now, is f prime differentiable at 0 or not? I mean, if you take the formula, of course it will not work, right? Because you will get a negative power of x when you differentiate. Now, f prime is not differentiable at 0. Why is that? Because the limit as x goes to 0 to f prime of x minus f prime of 0 over x minus 0. What is that? It's the limit as x goes to 0. What is f prime of x? It's 5/3 x to the 2/3 divided by x. This is 5/3 x to the 2/3 divided by x. This is x to the minus 1/3. Does that limit exist? It's 1 over cube root of x. Does that limit exist if you take x to 0? 1 over cube root of x. If x goes to 0, that thing's poof, right? Blows up, right? Do you guys see this? Yeah. 1 over 0. It's a kind of 1 over 0 thing. Does not exist. Okay? You guys see this? You see this or not? Yeah. Okay, so if you have a function that is differentiable at 0, it's not necessarily that it's twice differentiable at 0. Okay? Is that clear? Great, awesome. I mean, here we say that the graph, well, here notice that f prime is also continuous at 0. You see that f prime is continuous at 0, but it's not differentiable, right? Look at f prime here. It's continuous at 0, but not differentiable. And notice the graph of f prime, if you draw it, I mean, we'll look at this later, has a vertical tangent line at x equals 0. Okay. Anyways, we'll talk about this later. But anyways, okay. Let's do it. Okay. Awesome. Great. Now let's do a next exercise. Who volunteers for the favorite number? Someone who hasn't volunteered before? Okay, 3. F of x is sine 3x. No, let's do an easier one. Exponential. Oh god. Oops. E of 3x. Okay. I want you to find the. Who wants to give me their favorite big number? Someone raise their hand. Yeah?
17.
Okay. Sure. I'll be adding a 0. Okay. I'll just add a 0. Find the 1/70th derivative of x. Okay? Great. Now, what's the thing to do here? Let's try to find a pattern. Okay? You don't have to prove it rigorously, but let's try to find a pattern. Now, if you're asked to find these many derivatives, of course, I mean, you won't have to do them all, right? You just have to notice a pattern. Who can help me differentiating f? We're going to use the chain rule. Who can help me differentiating that? Who volunteers for that? No one? Yeah?
3 times
F prime of x, thank you. It's 3 e to the 3x. Are we good here?
Yeah.
Who volunteers for a second derivative, for your second derivative? Yeah?
9 e to the 3x.
Okay, 9 e to the 3x. How did you think about this? E to the x doesn't differentiate.
Does not.
It differentiates,
Yeah,
but it stays the same. E to the x differentiates, but stays the same, yeah?
So, with the chain rule, and then you bring the 2 down, and 3x differentiates.
Awesome. Thank you very much. If I may, I'll just write it in this way, okay? You agree? I brought the 3 down, and so I have 2 3s. 3 times 3 e to the 3x. Let's do one more. Can I differentiate the third time? Who wants to help? Yeah?
27 e to the 3x.
Sure? Can you write it in another way? Just in the same way I've written it here.
Sorry. 3 to the
3 cubed, thank you. Okay, who wants to volunteer for the fourth derivative? Yep. Okay. Do you guys see a pattern? So what's f170 of x? Who wants to volunteer for this? Yeah?
The 3 to the 170.
Exactly. Okay, are we good here?
Yeah.
Are we all good?
Yeah.
Any questions? No. Great. Awesome. Should you do one more like this? Should you do one more like this? Let's try to do one more like that. I'm thinking of something. Okay. I think we'll go a bit harder this time. Do you guys know the Euclidean division? Do you know how to Euclidean divide two numbers? You have a remainder and you have something like that, right? If I tell you divide like 99 by 4, what's the remainder? 3, right? Yeah? You see that? Yeah, 99 by 4. 100 is a multiple of 4, right? So 99 is minus 1 for a multiple of 4. And you add 4 to minus 1, so you get it's 3 away. Have you seen congruences? No, you haven't seen that? Congruence modulo. Have you seen that? No? Okay, that's fine. Okay, find if f of x. Who wants to give me their favorite number? Their favorite number? Nobody? Great, I'll just, yeah? 4, okay. F of x is sine 4x. Okay, here, are you expected to know this immediately? Is there a rule for this, or we'll just differentiate a few times and see that you have a pattern? What do you guys think? Pattern. Great. Let's differentiate that. Who can help me in differentiating f the first time? Who wants to help? Please raise your hand. Someone who hasn't spoken today, preferably. Yeah? 4 cosine 4x. 4 cosine 4x. Thank you. Let's differentiate twice. I don't want you to try to change the 4. I always want a 4 to appear, but I just want a power of 4 if you need that. Someone else who volunteers to differentiate that? Yeah?
Negative 4 squared sine 4x.
Thank you very much. The derivative of cosine is minus sine. 4x I differentiate, I get 4. So 4 times 4, right? You see that? Minus 4 squared sine 4x. Okay. Who wants to help for to differentiate the third time? Preferably someone who hasn't said anything today. Yeah? 4 cubed cosine 4x. You have a minus, right? Yeah, thank you. It's minus 4 cubed cosine 4x. Awesome. Let's look at the fourth derivative. Fourth derivative, who wants to volunteer for the fourth derivative? Fourth derivative, who wants to volunteer? Yes? 4 to the fourth sine 4x. Is that good? Are we all, do we all see what's happening here? Okay, now let us ignore the 4. Let us ignore the 4 to the power. Okay? Just ignore the 4. What is happening here? You have a cosine, right? You have a minus sign, then you have a cosine, then you have a minus cosine, then you have a sine. You guys see that? Everybody. Now, f to the 5, what will I get? Ignore the coefficients. I will get a negative sign, right? You guys see that? F to the 5, sorry, I'll get a negative cosine. I'll get a cosine, right? I'll get a cosine. F to the 6, I'll get a negative sign. F to the 7, I'll get a negative cosine. F to the 8, I'll get back a sine. Now the coefficient is just 4 to the power. You guys see this or not?
Yes.
Yeah? So if we were to do f to the 8 or f to the 7 just by looking at it, what do you get? 7 is like 3. You guys see this? 7 is like 3. You guys see that? Okay, so what do you have? You have minus 4 to the 7. Cosine 4x. And it was 3. Yeah, is that good? I think that's good, right? Yeah? Yeah. F to the 5 is 4 to the 5 cosine 4x. F to the 6 is minus sine. Yeah, that's good. Do you guys see this or not? Yeah? Now, if I were to look at f to the 99, what should it look like? F to the 99, yeah? negative 4, x 4 to the 99 cosine for x. Is that what you had? Yeah? Do you guys see that? You agree that 99 is like 3. Just keep counting. Right? 3 plus how many times 4 is equal to 99? 20? So, what is 99? 99 is 3 plus 96, right? 96 is what times 4? It's 24 times 4, right? So 3 plus 24 times 4 is 99, right? So 99 is like 3. You guys see it? And then derivative. So f99 of x okay? You guys see this? It's a bit tough. Just practice this a bit. And so people who raise their hands, you had this answer in mind? People, yeah? You had this answer? Okay, great. Awesome. Awesome. Let's move on. Maybe I want to talk a bit, well, I'll talk about this vertical tangent line business, but I think I didn't say anything about this, but yeah. I don't know if the book says anything about it actually. Oh. Okay, I made okay. Let g of x be equal to, I don't know, x f e to the x, where f of 1 is 2, f prime of 1 is 3, and f double prime of 1 is 4. Find g double prime of 0. I don't know, may I change it? I just put an x plus 1 here. Sorry about that. 1 plus x, okay? Sorry about that. Find g double prime of 0. Okay, so what do I have to do here to find g double prime of 0? I need to differentiate g, right? Once, and I need to differentiate it twice. You guys see this or not? Yeah? So differentiate g, what do you get? What do I use here? I have to use a product rule, right? G prime of x. Who wants to help me differentiate g prime? Who differentiate g? What do you have to use here? The product rule, right? You guys see this? Derivative of the first term, what is the derivative of this term? 1 times f of e to the x, right? Plus, I keep the first term fixed and I differentiate the second term. You guys see this? What's the derivative of the second term? F of e to the x. What is the derivative of that? Derivative of the inside. What's the derivative of the inside? E to the x times the derivative of f applied outside. Okay? We see that? Yeah. Differentiate twice. We need to differentiate again. What is this? Who wants to help? Who wants to help? No? No? Nobody? Yes?
E to the S times F, E to the S,
F or
E to the S times F of E to the S. And here is the product rule. Yeah.
right? Yeah. Okay. Plus, yeah. Product rule.
1 times E to the S, F times E to the S.
Okay, very good. So here I have three products. A product of three elements. Did we see any formula for that? No. Do we need any formula for that? What is your reasoning? I think what you were saying is that I'll take it as a product, I'll differentiate this times this. Great. So I have to differentiate this term. Yeah? Is that what you're doing?
Yes.
Yeah? So what is the derivative of this term? Yeah?
Is 1.
1, okay.
E to the S
Yeah?
plus E to the S plus this one.
Awesome, thank you. Yeah?
F double prime E to the S
Mm-hmm.
and to the other.
Into the other term. Did we forget something? We differentiated this term. Let's differentiate the
Times this. E to the S.
Okay. Thank you. Very good. We see that or not? We see that? This derivative is good, right? The first one is okay. Derivative of f e to the x is okay, right? Great. Now I want to look at this derivative. This is a product. You guys see this? It's a product, a times b times c. Now, I don't want to differentiate it as a product of three functions. What can I do? I can consider this as a product of this function times this function. You see that? It's this times this. You differentiate this one. You keep this one fixed. Right? Plus, you keep this one fixed, and you differentiate this. Is that good? Is it better? Yeah? Are we good or not? Yes or no? Do you see what's happening or not? It's a bit to simplify the tasks. Okay? I have a product. How do you differentiate a product of this function and this function? Differentiate the first one. Now, the first one itself is a product, so you differentiate it as a product rule. Luckily, you don't have any chain here, right? Just 1 e to the x plus e to the x, or x plus 1. Great, you keep the second one fixed. Now you differentiate the second one, this one, and you keep the first one fixed. Are we good here? Everybody, is it better? In the back? Questions? No? No? Yeah, we good? Is it clear? Okay, great. What is G double prime of 0? I mean, multiple choice, these are very good multiple choice questions on your midterm or your final. So you can have something like that. What is G double prime of 0? Let's see. What is e to the 0? E to the 0 is 1. So it's f prime of 0. It's e to the 0 f prime of 0. What is that equal to? E to the 0, e to the 0 f prime of 1, sorry. Right? You guys see that? E to the 0 f prime of 1. Okay, I won't try this. It's going to take a while, right? We'll just evaluate it immediately. E to the 0 is 1. So it's 1 f prime of 1. What is that equal to? 3, right? Plus, okay, what's this? This is x, this is 1, plus 1. You guys see that?
Yeah.
Look at here. Plug in x equals 0 here. What do you get? 1 here and 1 here.
Yeah.
So you get 2. Plus 2, f prime of 0. What is f prime of 0? 3. Plus 1, f double prime of 1. So it's 4. Times 1. You guys see this or not? This should be easy, right? Just plugging in x equals 0. Okay, plug in x equals 0. You will get this. So 3 plus 6 plus 4, what is that equal to? These are excellent multiple choice questions. Okay? Please, you should be comfortable in doing these examples. We'll be doing a bit more. Okay. I want to do an example from the book. This is the book, exercise 80. Find g prime of 1. This is problem 80 from your book. Find g prime of 1. Okay, this doesn't look nice, does it? But let us try to simplify that. Yes. It's exercise 80. Exercise 80 from the book. Okay? This is from your book, exercise 80. Find g prime of 1. How do we do this? Of course, you see, it's a chain inside a chain inside a chain, right? Is that complicated, or we just have to be careful? What do you guys think? We just have to be careful, right? If you're careful, then you'll be able to do it. Great. So first of all, I need to differentiate g. Let us take all our time in doing so. And if you feel you need time to do this, don't rush it, okay? Take your time, okay? Even if you take 5, 6, 7, 8 steps, just get it right. Okay? Don't try to do it mentally if you're not able to. Let's do this here. Now, the first thing I can realize is that g of x is f times something. F of something. So if I want to differentiate this, what do I have to do? I have to differentiate that something prime times f prime Is that good so far? Did I do anything very complicated? So far, no. Right? Now, is that term annoying you? Is that term annoying you? Is it? Do you have to differentiate this term anymore? G prime of x is the derivative of this term times f prime and this term. Do you have to differentiate it anymore? Or that's good? The term on the right hand side. Look at the term on the right hand side. Do I have to differentiate it again? Or I'm good? Everybody, please look at this more carefully. What is the term that I have to differentiate? Is it the left hand side or the right hand side? Or, yeah, the left or the right? The right hand term is nice, so I don't have to touch it anymore. So I have to differentiate the left hand side. Great. Now the left hand side, what is that? It's a product. You guys see this? The left hand side is a product. It's a product of x and f of that thing. How do you differentiate a product? Everybody? Okay, who wants to help me in differentiating this? So what do I have? I'll just do it. It's the derivative of x, which is 1, times f of x of f of x. You guys see this? Yeah? Plus, well, let me take my time and not rush it. I'll just write f and differentiate the second term. 1 here at my own pace. Okay, that's what happened. Again. Doesn't look nice, does it? Does it look nice? Doesn't. But this is left, right? Like it's not. Now, what is? Okay, no, this is good. This is very sad. What happens here? What is the term that is annoying me? It's this term. You agree? This term is good, this term is good, times this term and this is good. So I have to differentiate this term. I mean, ideally you wouldn't write, anyways, that's fine. This is just equals f. What is that again? F, okay, you have 2 f of x. One, two, 1, 2, okay. Plus x. I have to differentiate the term in brackets. So the derivative of x f of x times f prime at x f of x. Do you guys see this or not? Yes? Do you see this or not? Yeah? What's the derivative of x f of x? That I can do mentally. It's f of x plus x f prime x times z prime of x f of x. Oh, great. Is that good? No, that's not good. Let's see. No, I think that's x f of x, that's the derivative of that. Anything funny? No? Yeah? X f of x plus. Is the derivative correct? Yeah? The differentiate is correctly? Yeah, I think so. No, I have to. Is that good or not? Yeah? Do we differentiate this? Yeah? Try to differentiate it. Don't be afraid of differentiating. I'm missing the derivative of this thing, right? That's what I'm missing. What's the derivative of this thing? It's the derivative of the inside times f prime of this thing. Okay? So I have f prime of this thing here. I need the derivative of x f of x. What's the derivative of x f of x? Derivative of x is 1 times f of x plus x times derivative of f. Product rule. And that's what I get. Okay. Now let us evaluate g prime. What do I need to find? Find g prime of 1. So g prime of 1, what is that equal to? Can I raise? Okay, I'll lower this one. G prime of 1 and f, oh okay, I need, what is f of 1? What is f of 1? You guys have f of 1 is 2, so g prime of 1 is just f of 2, f of 1 times f of 1, so it's just f of 2, plus f of 1 is 2, and f prime of 1 is, what is f prime of 1? 4. So it's 2 plus 4 plus 2 plus 4 is 6, right? It's f prime of 2, right? Times f prime f prime of, what did we say? So f prime, f of 1, x is 1, and f of 1 is equal to 2, right?
Yep, yeah.
And f of 2, so it's f prime of f of 2. What is f of 2 equal to? 3. So it's 3. What is f prime plus of 2 equal to? 4? 5? F prime of 2 is 5. Plus 6 times 5. F prime of 5. This is 6, right? F prime of 5 is 6. So it's 33 times 6, right? Is that it? 33 times 6 is 188. Is that it? No. What about, no. 33, no wait. So it's 33, f prime of 5 is what? Oh, shoot, okay, thank you. F of 2 is 3. And f prime of 3 is equal to what? 6. Oh, okay, so it's 33 times 6. What is 33 times 6? 198. Is that right?
Yeah.
Now, I didn't, I may have made a mistake in this, but if you, did anyone do it independently? Or, yeah, did you get the same? Okay, anybody did it independently? Or anybody's trying it independently? You got the same? Oh, okay. But so far, is that, okay. Great, I mean, maybe we have 1 more minute. No. Anybody trying it independently just to be sure that they got the same? You got the same? You got the same? Okay, great. So have a good weekend and see you.